Hello and welcome to Console Cowboys. In the last video, we took a look at the difference between call and delegate call, and how the context of the calling method determines which contract address was affected. In this video, we're going to take a look at how memory is affected when using a delegate call that changes variables from within the logic contract in the context of the calling contract. Within Remix, I have a very simple example of a logic contract. And our logic contract, all it does is set the value A to whatever value is sent into this function. And it has one public uint variable of A. Now this by itself is no issue whatsoever until you introduce a delegate call. The calling contract I just pasted in uses a delegate call down here to call the set function in the logic contract and set the value that's sent in to the variable A. Now down here in our calling contract, we have a variable B and we have a variable A. And when we make this call with the delegate call, we're doing so in the context of the calling contract, meaning that the value A in the logic contract does not actually change. It's the value A within the calling contract. Or is it? Let's give that a try and find out. So if we compile our delegate memory, and then we deploy it, you'll see that we have our set function, our A and our B. So if we look at the value of A, it's the value 5. If we look at the value of B, it's the value 5. Okay, cool. So that matches up with this. Now, if we run set A, presumably our A variable is going to be updated. So let's do that. So we set that. We check our variable A. It's not updated. We check our variable B, that's updated to 7. So that's very interesting. And the problem is the logic contract only knows about A. It doesn't know about B. So it's actually updating the first slot in memory here, which happens to be B and not A, overwriting the value B, even though there's no function to set that. This becomes an issue when you have something like this. If you remember in our previous contracts, we had owner variables that then were checked to see if a function should run and if it was authorized for that user to run that function. Well, what if our B was actually the owner variable here and we sent an address in? So let's give that a try. So if we select the second address here, and then we change with set A, and we check it, now we've overwritten B, which is now the actual owner with the value of this address. And if we were trying to bypass authorization on a function and we're able to leverage a delegate call in this way, very bad things will happen. So hopefully that gives you some ideas when you see a delegate call, the possible implications of that. And now we'll head back into the blog where we take a look at a live attack on the blockchain against the Parity wallet attack where the delegate call was used to take ownership of a major smart contract wallet. Hopefully you learned something today. If you did, hit the like button, hit the subscribe, and share this out to your friends or anybody else who you think will enjoy it.